Hey guys, in this video I'll talk about related rates, which is an application of differentiation where we try to find the rate of change of a function that depends on another function that we already know the rate of change of, or we can find the rate of change of. So let's look at this problem. The circumference of a circle is increasing at a rate of pi over 2 meters per hour, and at some point the circumference is 12 pi meters. So you want to find the rate of change of the area of a circle at this point. So we can draw a diagram so we can visualize this. So this circle is expanding and the circumference is increasing at a rate of pi over 2 meters per hour. And you want to find the rate of change of area when the circumference is 12 pi meters. So let's first write the equation for area, just pi r squared, the area of a circle. And we'll differentiate each side with respect to time. So we see dA dt, the rate of change of area with respect to time, is equals to pi times 2r using the power rule, and using the chain rule, times dr dt, the derivative of r with respect to t. So this is the value that we're trying to find, the rate of change of area with respect to time. And in this function, we don't know right now the value of r and the value of dr dt. So if we find these two values, we can find the rate of change of area. So let's first find r. We know that circumference is 2 pi r, and we're given that the circumference is 12 pi meters. So writing this equation and solving for r, we see that r equals 6. So now we got this value, we know what r is, and the only value that we're left to find is dr dt. If you look at the problem, the only piece of information that we didn't use is that the circumference is increasing at a rate of pi over 2 meters per hour. So now let's use that information. We know that circumference is equal to 2 pi r, and differentiating each side with respect to time, we see dc dt equals 2 pi times dr dt. And we know that this is equal to pi over 2 because the rate of change of the circumference is pi over 2 meters per hour. So now here we're given an equation, and the only unknown is dr dt, which we can solve for. And we see that the rate of change of the radius is 1/4 meters per hour. So now we know r and we know dr dt, so we can just plug in these values to find the rate of change of area. Doing this, we see 3 pi. So dA dt, which is the rate of change of area with respect to time, is 3 pi meters squared per hour.